Hey guys, welcome to day 4, another day on chain rule. Just so you guys know, these questions take a decent amount of time, so you're going to be pausing and doing the questions on your own and then making sure that you have the correct answers. So just know that for this lesson. But let's start. We've got the idea of sine of 2x, and with this, remember that the rule that we stated last time, and this shows it nicely right here. The derivative of the main function, keep the inside the same, times the derivative of the inside. And that's the key here. The big function here, f of x here, is sine x. G of x is 2x. And so when we do this, when we take the derivative, we can say that this equals, the derivative sign is just that, so we just put an equal sign. The derivative of that equals the derivative of sine x, cosine x, keeping g of x, which is 2x, so keep the inside the same, multiplied by the derivative of the smaller function, the 2x here, the derivative of 2, and so we're just going to get 2 cosine of 2x. With this one, we can rewrite this. We can say that equals the derivative of sine of 3x all, I want to put that there, squared. A little more work here. This was a simple composition. This is a composition within a composition. So we take the derivative of the main function, which is something squared. So we can say this is 2, keeping the inside the same, sine of 3x multiplied by the derivative of the next main composition. When we took care of the something squared, so now we're in the sine. The derivative of sine is cosine, keeping the inside the same, multiplied by then again the smallest one times 3. And so we can state that 2 times 3 is 6, so we can get 6 sine of 3x multiplied by cosine of 3x. And that's our answer. So I want you to look at this one, and this is one that you're going to do on your own. Notice here that we have y equals the square root of x multiplied, make sure you realize that it's multiplied there, by tan cubed of the square root of x. And so we're going to have product rule. So with this, what I would suggest is find the derivative of the square root of x, find the derivative of this, do that separately, and then combine them. Do not try to do this within one step here. Do it separately. So I'll come back with the work. Pause it, please. And so I hope, I haven't finished this yet, I haven't simplified it, but I hope this is what you got. Got the derivative of the first one, 1 over 2 square roots of x. And let me tell you guys something. If you can memorize that the derivative of the square root of x is 1 over 2 square roots of x, it's going to make your life a whole lot easier. I promise you that. Know that the derivative of square root of x is 1 over 2 square roots of x. It's just going to make your life easier. The derivative of tan cubed square root of x, you can see right here. The derivative of something cubed times the derivative of tangent, which is secant squared, times the derivative of the square root of x, which is 1 over 2 square roots of x. So here's our answer right here. You have the derivative equaling the first times the derivative of the second plus the second times the derivative of the first. And what I need to do here is simplify this. And so notice that with this second part, the addition part, this multiplied, the tan cubed square root of x multiplied by 2 over square roots of x, nothing simplifies. This square root of x cannot simplify with that square root of x. So we're just going to get tan and then for the first part, we have square root of x being multiplied by all of this. By all of this. And so therefore, notice that we have the square root of x here and the square root of x in the denominator here. Those can cancel, just so you know. And so therefore, we are left with 3 over 2 tan squared square root of x multiplied by secant squared square root of x. And that's our answer right there. And we're done with that. You could have found common denominators. There's no reason to. You could have pulled out a 1/2. There's not a good reason. I mean, you could have pulled out a 1/2 tan squared square root of x, because that is a 3, and been left with. So we could have done this. Computer is glitching, so I'm just going to give you a right to the answer. We could have taken out a tan squared square root of x and a 1/2, a 2, and been left with 3 secant squared square root of x plus tan square root of x all over square root of x. So that takes care of the first page. Let's go on to the second page. And you guys can try this one. I will, again, have the answer there, but we're going to go right into the second one. So if you want to try it, pause it, and I'll get you the answer. So I have two ways that I did it here. I did the find f prime of x using the f of g of x way. So I found the actual f prime of g of x times g prime of x. I found f prime of x here. Notice that this is another chain rule, so I take the derivative of the square root of 2x plus 3, which is 1 over 2 square roots of 2x plus 3. Then you have to multiply it by the inside, which is times 2. So these 2's cancel, and that's why those 2's are gone. Make sure you realize it's the derivative of the inside here, which is the 2. I found g prime of x, which was 3x squared. I then found f prime of g of x, this part right here. I plugged in x cubed minus 5. Oops, but I forgot my plus 3 here. Which would make that a plus 3. And then I multiplied by g prime of x. And what you notice that these are equivalent, now that I have the added 3 here. Just distribute the 2 to get minus 10, then plus 3. What I did over here in purple is I found what f of g of x was first, distributed, and then took the derivative of what f of g of x was without using the rule. Either way is fine. Do not think that one way is better than the other. It's not. Either way is fine. I find this way to be easier, but that's just me personally. So with this one, this 3 right here needs to be brought out. Okay? So what we have is h of x equaling f of g of 2x cubed, all raised to the third. So we have one main function, then another, then another, and then another. So you should be taking the derivative 4 times. Okay, so pause this, try to take the derivative of it, plug in 1, and see what you get. Good luck. Pause it. So hopefully you got 3600. If you didn't, please pause it, figure out where you went wrong. I think all the steps are pretty clear right here, but you had to find h prime of x first, and then I plugged in 1. So pause it if you didn't get it, but we're going to move on. So the next idea is the derivative of an inverse function. Probably won't, maybe not one of the most difficult things, but not necessarily the easiest. So, derivative of an inverse function. So if f is differentiable and f inverse is the inverse, then we know that the composition of the two equal x. We should have learned that in pre-calc. That f of f inverse of x equals f inverse of f of x, which always equals x. That's how you can always tell if something's an inverse or not. The function of the inverse of that same function equals x, you know it's good. So, if we have x to the 4th plus 2x cubed, says this is going to lead us, it's the beginning problem, it's going to lead us. Find f of 1. Well, f of 1 equals 1 plus 2, 3. Find f prime of 1. Well, let's find f prime of x first. 4x cubed plus 6x squared. So f prime of 1 equals 4 plus 6, which equals 10. So now it says find f inverse of 3. And to find f inverse of 3, we know that if f of 1 equals 3, the inverse, which we all know that the inverse switches the x and y, that f inverse of 3 then must equal 1. If they're inverses, they have to be switched. So we have the point 1, 3. The inverse point is 3, 1. So now it says find the derivative of the inverse of 3. Well, we've got to figure out what this derivative is. So let's take a minute here and find the derivative of this. We've got to find the derivative of this. So what we're going to do here, find the derivative of the big function. That's f prime of f inverse of x, okay, multiplied by the derivative of the inside. Now, I don't have a great way of writing this, so f inverse of the derivative of x equals 1. And what we're trying to solve for here is the derivative of the inverse, which is this part. So if I can solve for the derivative of that, we'll write it as that. Well, how do I get that alone? Well, I divide by this over to this side. So 1 over f prime of f inverse of x. This is something that you guys are going to need to know. The AP always asks questions on this. Always. So all we're going to do here, and I say all, it should look fairly simple after I go over this. It's going to take a little bit of you guys for getting used to. F inverse prime of 3, which equals 1 over f prime of f inverse of 3. Well, that equals 1 over f prime of the inverse, which we already found was 1. And hey, we found what f prime of 1 is, which is 10. So it's just 1 over 10. So again, just to recap, f inverse f prime of 3, we set that equal, we found out what it was equal to, so we set it equal to that. We substituted in 3 for x. F inverse of 3 we found was 1. And now we have f prime of 1, which we found was 10, so we get 1 over 10. For our last example here, we're going to have let f of x equal 4x minus 2 cubed. And let g of x be the inverse function of f. So I've said g of x equals f inverse of x. Given that we have the point 0, comma, negative 8, find the value of g prime of negative 8, which is the derivative of the inverse at x equals negative 8. So, going back from our last example, we know that the derivative of the inverse of x equals 1 over f prime of the inverse of x. So we can rewrite that down here. And so we've got f inverse prime of negative 8. That's the same thing as saying g prime of negative 8 due to this substitution, which equals 1 over f prime of f inverse of negative 8. Well, the goal here is that we have the point 0, negative 8. If we have the inverse, we know that the inverse is the inverse of negative 8 equals 0. We just switch them. And so therefore we have that right here. F inverse of negative 8 is 0. So we can write that that equals 1 over f prime of 0. Well, f prime of 0 we got to figure out. So let's go over somewhere else. And we can find f prime of x. Well, the derivative of this, bring the 3 out in front. Keep the inside the same, square, because we subtracted 1, multiplied by the derivative of the inside, 4. So we're going to get 12, parentheses, 4x minus 2 squared. So we know that f prime of 0 then is 12 times negative 2 squared. 4 times 12 is 48. So we can substitute that in to then get us 1 over 48. And so for this last one here, I have it worked out. If you want to work on it, great. If you don't, we can look at it in class. I know I've been lacking on my jokes, so here it is. Dear Algebra, please stop asking us to find your x. She's never coming back, and don't ask why. You guys have a good day.